This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please don't share personal information during the class for your own security reasons. All right, so here's what I am curious to know today. This is actually going to be related to our lesson as well. I want to know, what do you do, or what would you do if or when two of your friends are having an argument? Go ahead, tell me in the chat box or on the whiteboard. What do you do when two of your friends are having an argument? Or what would you do, right, if two of your friends had an argument? Go ahead, tell me either on the board or in the chat box. Go ahead, let me know. Awesome, I got an answer from Dolly. I see Dorian typing. Dorian, try that again. I just see a bunch of boxes, so I don't know if you typed that correctly. Awesome. Hi, Shoshana. Good. I see your answer on the board. Let's get some more participation up there. Tell me, what are you going to do? Or what have you done when two of your friends were fighting? Or if two of your friends eventually fight? Go ahead, tell me. Awesome. I see Noah on the board. Looking good. Get your answers up there. I'm going to go ahead and put those links in the chat box as well again, now that we've got some more people joining us. Awesome. Blossom, Jody, Michelle, Whitney. Hi, Ethan. Hi, Chanel. Go ahead, open up their tickets, those tickets. Awesome. Looking good. Going to give you another 30 seconds or so. Get your answers up there. Awesome. I see Efren on the board. Looking good. All right, cool. Let me go ahead and start going over these answers up here. So let's see here. Shoshana, you'd say you would tell them to stop, let them have some space away from each other, right? Give them some time to cool down, right? Noah, you said you would tell them to calm down, right? Give them some advice on how to deal with those emotions. Let's see here. Wouldn't do anything, Efren. You would just let it play out the way it plays out, right? And Dolly, you said you would sit there because you're not sure what to do, right? I see, Dorian. Are you learning Korean? That's cool. And TJ, you said you would do 3 1-minute rounds boxing match. That I feel like would maybe be successful. Depends on if both of your friends know how to box, right? If one of them knows and the other one doesn't, that might end up badly. Looking good. All right. So I like how we're thinking about these solutions here. So a lot of times, right, if two of our friends are having issues with each other, right, they're friends with each other, but they're also friends with you, a lot of times they'll come and talk to you about it, right? So you're kind of a sounding board. You get front row seats. Yeah, Efren, why do you have another class at this time? You shouldn't have another class at this time. That's so weird. What's the other class that you have right now? History? Yeah, you should be scheduled so that you don't have a conflict. Okay, that's fine, Efren, just make sure you save the password and then let me know if you have any issues later, okay? Hi, Era. Hi, Ashton. How are you? Hi, Rosie. Looking good. All right, so this is related to today because today we are going to be talking about the concept of buffers. And in everyday situations, a lot of times if there is no lab due today, no. If there was a lab due last week though, so make sure you finish last week's lab if you haven't already, the Unit 8 lab. So a lot of times we act like buffers, which means that we help to kind of keep the situation calmer, right? We help to keep our friends a little bit more separated. We help them to calm down. Smiley faces, if that makes sense. This idea of a buffer. Right, so buffering is a scientific principle, but it's also kind of a principle that you use every day whenever you try to help your friends who are in a fight with someone else. Okay, looking good. So let's go ahead and open up our tickets. All right, I got a lot of people jumping in here, so give me a green check once you have your ticket open. Password is in the chat box. I've got 8 green checks so far, 10 now. Perfect. Red X's if you're having any issues. Just want to make sure there's no problems logging into the attendance ticket. Love it. All right, don't see any red X's. I'm going to move on here. There are only 9 days left of school. We are officially in the single digits. Go ahead, give me a smiley face if that makes you happy. It makes me very happy. I'm excited about summer. It's so close. I'm excited about graduation because I know a bunch of you are graduating. It's going to be great. Cool. So there's only a few days left of school. We really got to make sure we're getting everything turned in. Remember, guys, what are the two main categories of assignments that are the most important to my course? Tell me in the chat box. What are the 2 main categories that are most important? So it's 10 days including today, but not 9 days if you don't include today, right? We've got Tuesday, Wednesday, Thursday, Friday of this week, and then Monday through Friday of next week. So in total, 9 days starting tomorrow, right? Yeah. Either way, though, you got to know it's ending soon. Looking good. Sorry, I asked a question. What was the question that I asked? Oh, what are the two biggest categories? Yes, Noah, exactly. We got to make sure we do labs and quizzes. If you get perfects on all of your quizzes, it doesn't matter. The highest grade you can get in the class with only quizzes is a 40%, which is not passing. If you do your labs and your quizzes, though, that gets you a 65%, which allows you to pass the class. Remember, each lab is worth 5%, which is actually the same amount that a single exam is worth. But you actually have more labs than exams, right? So you actually only have, let's see here, you have five labs, which actually totals to 25% of your grade, and you have two exams that actually only total to 10% of your grade. So in fact, labs are more important than exams, and I need you guys to do your labs. All right, smiley faces, everyone, if that makes sense. Dorian, you say you're going to work at GameStop as a summer job to save up for college. Sorry about that. Oh, that's super cool though, Dorian. Yeah, I don't think I'll need discounts, but that sounds really awesome. Good job getting work done during the summer. Cool. All right, so this week, let's take a look at our schedule. We are finishing up Unit 9 today. We were actually supposed to have a Unit 9 lab, but I'm actually cutting it out just because I really want to make sure next week all we have is the final exam and then the end of school. So I didn't want to have anything else to focus on next week except for the final exam. So lucky you guys, you do not have a 6th lab. Go ahead, give me a thumbs up if that makes you happy. Makes me happy too. It's less grading for me. Looking good. All right, so that means tomorrow you will have a game day that goes over both Unit 8 and 9, because remember we skipped the Unit 8 game day, so we're combining it tomorrow. And then we're doing Unit 10 Wednesday, Thursday, talking all about organic chemistry, which is chemistry in the body. And then on Friday we'll have our game day for that unit, and then that means next week all you have left is your final exam. That'll be Monday, Tuesday, and then Wednesday, Thursday, Friday are no new assignments. So those are just days to make up anything that you're missing. Make sure that you are passing your classes. We'll still have live session, but live session will just be a quick check-in. I'll give you your last word and then you'll be good. So it's like a 5-minute deal each day for those attendance tickets, Wednesday, Thursday, Friday. Cool. All right. So today is Monday the 3rd. All right. So again, we only have 9 days left, right? Tuesday through Friday and then Monday through Friday. The last day of school is on Friday the 14th. Courses are going to close at 11:59 p.m., 1 minute before midnight. Do not wait until the last minute to turn things in because, again, K-12 does have a tendency to crash during that last hour. So try to have everything in by 11. Okay, so this unit we've been talking about acids and bases, right? We started talking about this on Friday. We learned the definitions of acids and bases. Today we're going to talk a little bit about what the pH scale is. Go ahead, give me a smiley face if you've ever heard of pH. Go ahead to give me a smiley face. Maybe tell me, where have you heard the term pH? I can think of 2 really good examples that you might hear of with pH. Yes, okay, so we've got people that have heard of it. Yes, with water, right? Specifically, right, think about pools. A lot of people talk about pH when they talk about pools, or as well as fish tanks, aquariums. pH is important in aquariums. And we'll talk about some acid-base reactions as well as what a buffer is. Okay, and again, that goes back to what we started off with class. So today we're going to talk about the different components of a neutralization reaction. This is actually kind of a review, so this should be a fast review for neutralization. We'll talk a little bit more about bases and acids, how they react with each other, and we'll talk about buffers, how they resist changes in pH. We'll talk about pH and identify some various different kinds of buffers. Okay. So that being said, this term pH is really important. pH is our acid-base scale, and if it's below 7, that means that something's acidic. If it's equal to 7, if you have a pH equal to 7, it means it's neutral. If it's above 7, it means that that substance is a base. And the way that we measure pH is by understanding the amount of hydrogen ions that are in solution. So let's go ahead and break that down. Now, here's the deal, guys. All liquids are either acidic, basic, or neutral. Everything falls on this scale somewhere. Okay, so to determine this, we use the pH scale where 1 is the most acidic, 7 is neutral, and 14 is the most basic. Go ahead, give me a smiley face if that makes sense. So it's a 1 to 14 scale. All right, 1 is most acidic, 14 is most basic. Now, this is sometimes hard to think about because when we think of acidic, right, we often think about like this is really high, ouch, like it hurts, but really we actually use the smallest number for acidity. Okay, so acid is actually closest to 1. So, for example, pH of 2, which is highly acidic, is actually the acids that are in your stomach, which we call gastric acid. So you actually have something super acidic in your stomach already, which is also oftentimes also related to why people get issues with like heartburn or with ulcers, is because of the acidity of their stomach. But your stomach is actually really good at containing acidity because your stomach is constantly renewing its cells and it can survive really harsh acidic environments. Okay, tomato juice, for example, is a pH of 4, so that's much less acidic, right? It's between highly acidic and neutral, so it's just a little acidic. Urine, human urine, is a little bit acidic, right? pH of 7 is neutral, and that would be pure water. Pure water is neutral. Your blood has a pH of 7.4, which puts it slightly on the basic side. Smiley faces if that makes sense. It's actually slightly over here, more towards the basic side, The soap that you use, right? We talked about how soap is slippery and bitter, and so that is more basic. That falls near 10. And then household bleach is a very strong base. Remember, we talked about bases can still be really dangerous, not just acids, and that falls on a pH of 12, which is really close to the highest basic pH. Okay? So what is pH? So the word, the abbreviation pH actually stands for hydrogen potential, right? So the P means potential, the H means hydrogen. So pH, hydrogen potential. So what it's actually doing is when we measure pH, we actually measure the concentration of hydrogen ions in solution, H pluses. Because remember, the more H pluses there are, the more acidic something is, because acids release H pluses. Thumbs up if that makes sense. Remember, acids release H plus. More H plus means more acidic. More H plus means more acidic. Awesome. Thank you, Arrow, for your thumbs up. More thumbs up again, if that makes sense. Acids release H+. Thank you, Caleb. Thank you, Noah. Thank you, Orlando. Perfect. So here's the thing. This is actually kind of the reverse. So it's a little bit weird to think about, but pH actually has the reverse trend. So if you have a low pH, like a 1 or a 2, that actually means that you have a lot of hydrogen. So low pH actually means high hydrogen ion concentration, meaning it's acidic, right? So you can see that over here, right? This is an acid, and you can see all these little gray pieces are H plus ions. Okay, so we've got high H plus, high hydrogen ions, which actually makes a low pH, like a pH of 1, which actually makes it acidic. Okay, so again, these are kind of opposites. High H plus means a low pH, which means acidic. Okay, now on the opposite side, a high pH means that there's low hydrogen ion concentration. Again, they're opposites, making it more basic, because remember, bases actually release OH negatives, which are the opposite. Okay, so you can see that over here, we've got a bunch of OH negatives. So this means we have low H plus, and therefore a high pH because they're opposite, like close to 14, and this would be basic. All right, one last time, go ahead, give me a thumbs up, everyone, if this is making sense. Again, pH and H pluses are opposite. They have opposites. All right, so go ahead, fill in number 1 in your ticket. You have 30 seconds. Fill in the blank with the word hydrogen. Go, go, go. All right, waiting on a green check from Amanda, Amir, Ashton, Bradley, Brianna, Chanel, please. Green checks, Dree, Dylan, Edwin, Elias, Ethan, R, Ireland, Jacob, Jasmine, Matt, Michelle, Rozzy, TJ, Whitney, Yolese, green checks for number 1, filling in the blank with the word hydrogen. And we're moving on in 5 seconds, and I'm not going back, so if you miss it, you will have to watch the recording. So make sure you're paying attention and following along as we go. Awesome. Let's keep on going. All right. So that being said, right, we talked about last week how we can use a paper called litmus paper to figure out if something is an acid, a base, or neutral, right? We had red litmus paper, blue litmus paper. We know if they both turn blue, it must be what? B for what? Tell me in the chat box. B for what? If litmus paper turns blue, that B means it must be what? Basic, yes. If they both turn red, it must be therefore what? If they both turn red, it must be the opposite, which is the acid. And if they don't change colors, right, if you try both of them and neither of them changes, what does that mean it is? Tell me in the chat box. What does it mean it is if neither of them change? Yeah, neutral, right? So litmus paper is super useful to identify acid, base, or neutral. However, it can't be more specific. It can't tell you if it's more basic or less basic or more acidic or less acidic because, right, it just has two colors, red or blue, right? So you can't be more red than red. Smiley faces if that makes sense. So litmus paper is helpful, but not as helpful as it could be, okay? So this should make sense, right? So we've got different substances that get ranked by their pH. So for example, car battery is super acidic, has a pH of 1, water is neutral at 7, bleach is very basic at 12, but again, litmus paper can't tell us anything besides acid, base, or neutral. So instead, there are other indicators that actually allow us to get more precise pH values. So you can see this down here, this rainbow of colors, and you can see that what we can do is we can actually test these different substances with these indicators, and based on the color that you get, whether it's pink or orange or green or purple or magenta, you can figure out its actual pH value. So that's why pH is super important, and that's why we use what's called pH paper. All right. So I have right here, these are called pH strips or pH paper, and these ones will actually turn many, many different colors. All right. Can you guys see all these different colors that you can get? So you can see like reds over here are for very acidic. You can see orange and yellows are for less acidic, greens for neutral, dark greens, blues for basic, and then you got really dark blue for very basic, all right? So what we're going to do is we're going to actually test a few substances, and we're going to figure out what is this going to be? What is its pH going to be, okay? So let's go ahead. We're going to try this out. All right, and I'm going to go ahead and grab, let's see here. Let's go ahead and grab first some lemon juice, okay? Yeah, so you can use pH paper to test whether or not water is too acidic or too basic, right? Which again is important in things like pools or in things like aquariums because fish can only tolerate certain pHs. All right, so here we go. I'm going to go ahead and test some lemon juice. All right, and go ahead, take a look at that lemon juice. Tell me what color did it change? Take a look at this chart down here. Take a look at the color it changed and tell me about what pH do you think lemon juice is. Go ahead. Tell me what color did it change or what number do you think it's close to? Yeah, it looks kind of orangish, right? So that might be which numbers? Which numbers? I think 5 is more yellowish actually. So I don't think it's quite 5. Which ones are more orangey? Yeah, 3 or a 4. Yeah, it kind of looks like a yellow orange. So I would say lemon juice has a pH of about 4, right? Smiley faces if that makes sense. So the pH paper for lemon juice kind of turned yellow orange, which means a pH of 4. Awesome. All right, let's go ahead and try Windex. All right, do you guys know what Windex is? It's used to clean windows. Yes, this blue liquid right here. All right, let's go ahead and try this one. Oh my gosh, look at that change colors. All right, take a look at that. What do you think the pH of Windex is going to be? What do you think the pH of Windex is going to be? Yeah, it changed color drastically, right? So I can even show it to you next to here, right? So where do you think this might be? I would say it lands probably right about here. Yeah, I would actually say it's like 11, right? It's quite blue. It's close to 11, right? It's not super, super dark yet, so we know that it's kind of a lighter blue. So I would say it's about 11, right? Andres, we're testing the pH, the acidity or basicity of various liquids. All right, so we've got Windex, which was kind of a light blue, and so we would say that's a pH of about 11. Right? Okay, let's go ahead and take a look at, let's see here, just plain water. Let's take a look at plain water. All right, so I've got this. What did you put that made it blue? Oh, Windex. All right, so let's go ahead and try just plain water. All right. And what color did it change with plain water? Hopefully we should know what it should be. Yeah, so it probably means that my water is slightly acidic, which is fine because it's not pure water. It's just water from the faucet. So yeah, it's about 6 or 7, right? So 6 or 7. If it was pure water, hopefully it'd be a little bit closer to 7. So water is kind of light green. So it's probably closer to 7. Again, at my house, it might be slightly acidic. All right, so we go ahead. We'll do one more. Let's do vinegar. Let's take a look at vinegar right here. Get some more paper. Here's some vinegar. Test this. All right. Maybe. There you go. And what color does the vinegar change? What color did the vinegar change? Okay, got some answers for 4, for 5. It might be a little bit hard to see. Let me see if I can get my pH paper here. So if I were to match this up, this would actually match up with about a 2 on the chart here, a 2 or a 3. So this one would also be more towards like lemon juice, right? So vinegar was kind of orange, so it'd be more towards a pH of 2 or 3. Okay? No worries about that. I'm glad you were able to make it, Israel. All right, cool. So we got all these pH papers. They changed their color. So let's go ahead and talk a little bit about what these are. So lemon is a pH of 4. So what do you guys think? Is that a strong acid or a weak acid? Is it closer to 1, which is strong, or closer to 6, which is weak? Go ahead, tell me in the chat box. What would this be? Yeah, this would be a weak acid, right? So lemon juice is a weak acid. Awesome. What about Windex? pH of 11. What do you think that's going to be? Is that going to be a strong acid, a weak acid, neutral, a weak base, or a strong base? What do you think a pH of 11 would be for Windex? Yeah, I would say it's a little bit more towards the strong side, right? So I would say this would be a strong base. Awesome. Or at least a stronger base. Water, what is water? If water has a pH of about 7, what is water? Go ahead, tell me in the chat box. Yeah, water is going to be neutral, right? Neutral meaning it's neither acidic nor basic. And what about vinegar? Vinegar had a pH of 2 or 3, so what would that be? 2 or 3. Go ahead, tell me weak or strong, acid or base, neutral. Weak what? Strong acid, strong what? Yeah, be specific. So yes, this would be a strong acid, right? Because it's more towards 1. Awesome. Go ahead, give me a thumbs up now, guys, if this makes a little bit more sense, understanding pH, the pH scale, how we test for pH, now that we've seen it in person. Excellent. Looking good. All right. So that being said, right, we've talked all about pH. We've talked about acids and bases. So why is this important? Remember that acids and bases can neutralize each other, right? An acid can neutralize the properties of a base, and a base can neutralize the properties of an acid, okay? So for example, hydrochloric acid is a very strong acid with a pH of 2, can burn your skin. All right, sodium hydroxide, which is NaOH, sodium with an oxygen and a hydrogen, is a very strong base with a pH of 13. Again, very strong, can burn your skin off. So alone, they are both very corrosive and very dangerous. However, if you mix them in the right amounts, the strong acid and the strong base actually will neutralize each other, causing a neutralization reaction. And what does the word neutral mean again? Tell me in the chat box. What do you think of when you hear the word neutral? What do you think of when you hear the word neutral? Yeah, you think of things like water, right? You might think of the word like nothing or canceled out, right? Or 0, right? So it's neither acidic nor basic. So neutralization means that it's neither acidic, neither basic. It's even, it's halfway between them. Exactly, Andres. So what actually happens is they will form sodium chloride, which is a salt, and water, which again has a neutral pH. So they literally neutralize each other. And is salt going to burn our skin off? Is sodium chloride, table salt, going to burn our skin off? Is water going to burn our skin off? Tell me in the chat box, is water? No, right? So this is really important because you can take two things that are super strong and neutralize them to the point that they can no longer even hurt you. Okay? So that should make sense, right? So we get the OH from our base, we get the H from our acid, they come together and they make H2O, 2 H's and an O, for our water. And then the remaining two parts, the sodium and the chlorine, come together to make salt. They make salt and water. And that's what all neutralization reactions do. Acids and bases will always create salt and water. Go ahead and answer number 2 in your ticket. Give me a green check when you have it saved. You have 30 seconds. Fill in the blank with the word neutralization. Make sure you spell it correctly. Waiting on green checks from Amir, Andrea, Andres. Thank you, Andrea. Waiting on Ashton, Bradley, Brianna, Chanel, Dree, Dylan, Edwin, Elias. Thank you, Israel. Waiting on Jacob, Jasmine, Matt, Michelle, TJ, Whitney. The really important thing to also understand about this is if, for example, you spill something in a lab that's a strong acid or a strong base, before you clean it up, it's important to neutralize it with the opposite, right? So a lot of times if you spill something acidic on the floor in a lab, right, they will then throw baking soda on top of it, which is a base, to try to cancel it out so that it's not as dangerous and won't eat through the floor and won't eat through anybody's skin, all right? Cool. All right, let's go ahead and keep on going. So the last thing that we need to talk about today is buffers. And remember, we started off talking about class about how sometimes we act like buffers between relationships. When two of our friends are fighting, we help to kind of buffer that situation and help to keep it calmer and not going to any extremes. So here's what happens. Buffer reactions actually do the same thing for acids and bases. They help from a situation or a solution becoming too acidic or too basic. Okay, so buffers are solutions that resist pH changes when you begin to try to add more acid or more base to that solution. So they bring the pH much closer to 7, again, which is neutral, and they're neutralizing any additional acid or base to that solution. Okay, smiley faces if that makes sense so far. So buffers help to keep solutions from extremes, right? They're neither too acidic nor too basic. Just like real life situations, buffering between friends, you keep it from getting too violent or too extreme, right? Now, what they're actually made up of is buffers are made up of a mixture of a weak acid, which we're going to represent as HA. A could be anything. It's just as long as it has the H, that tells us it's hydrogen. And its conjugate weak base, so its opposite, which is basic, A minus. Okay, so again, that A could be many different compounds. It's just the opposite without the hydrogen. Okay, so we've got a weak acid and a weak base represented here, and we're going to show you how a weak acid and a weak base can actually resist pH changes. Okay, so this is number 3 in your ticket. Give me a green check when you have it saved. 30 seconds. Go, go, go. Fill in the blank with the word resist. Resist. Go. Waiting on a green check from Amir, Ashton, Bradley, Brianna, Chanel, Damien, Dree, Dylan, Edwin, Elias, Jacob, Letty. Green checks for number 3. Fill in the blank with the word resist. We're moving on in 5 seconds. Cool. All right, let's keep on going here. All right, so how does this work? How do buffers actually work? So here's the deal. If you try to add a strong base to this solution of a weak base and a weak acid, the weak acid is actually going to give up some of its hydrogens in order to transform that strong base into water. And so the result is, if it turns it into water, is water going to change your pH a bunch? Tell me in the chat box, is water going to change pH very much? No, it's already neutral, right? So if this solution is close to neutral and we're just turning this into more water, it's going to stay neutral and your pH will only change slightly. So this should make sense. So we can see here in solution, right, we've got some acids right here, some weak acids here, and we've got some weak bases here. Okay, so when we try to add a strong base, right, which are these OH negatives right here, these right here are the strong base. So we'll call that OH negative. OH negative, which is the strong base. And remember, the weak acid, right, was HA. The weak bases were A minus. Okay, so here's what happens. The strong base is going to interact with our weak acid right here. And so this weak acid will actually give up one of its H's, okay? And as it gives up one of its H's and donates it to that strong base, so we're going to take this hydrogen, rip it off, and donate it to that strong base right there. What does H and OH make? What does adding a hydrogen to an OH make? 2 H's, 1 O makes what? Tell me in the chat box. 2 H's, 1 O makes what? Yeah, it just makes H2O, and H2O is water. So these two things are able to cancel out to just water, right? So they cancel out to water. which is neutral. And what's left over? We can see we have left over A minus, right, because we pulled off that H. But A minus right here is just our weak acid, or is just our weak base, which our solution already had a bunch of weak base. So if you add more weak base, is that going to change your pH a lot? Tell me in the chat box. Is that going to change our pH a lot if we have some more weak base? Think about it, it's just weak base. Is that going to change your pH a lot? No. So by doing this, we have some leftover weak base. We canceled out some of that OH to water. And so overall, you have almost no change in pH. So these two things mean there's no change in pH. Okay, go ahead and give me a green check, everyone, if that makes sense. Green checks if that makes sense. So the weak acid cancels out the strong base, resulting in almost no change in pH. So that is why it buffers. Awesome. Now let's do the opposite. So the opposite is if you add a strong acid. So now if we add a strong acid, now the weak base comes into play. Okay, so again, we can see here, we've got our weak base here, weak base, which is A minus. We've got some we've got some weak acid here, which is HA. And now we're going to try to add some strong acid. So we're going to try to add some strong H pluses from an acid. But here's the problem. When you add a strong acid, which is H plus, it's just going to react with the weak base, right? So we've got our strong acid right here, strong acid contributing some hydrogen ions. We've got our weak base right here. And when H plus and A minus react with each other, all they create is HA. And what is HA? Tell me in the chat box. Take a look at our picture down here. What is HA? What is HA? We just talked about this. HA is what? It's weak what? Be specific, right? There's two weak things. HA, though, in particular, is the weak what? Yeah, so we end up just creating weak acid. And is weak acid going to change our pH a lot? Will more weak acid change our pH a lot? No. So there's, again, barely, so basically no change in pH. Right? So again, the weak base is able to cancel out the strong acid, resulting in almost no change in pH. Smiley face if that makes sense. So either way, by having a weak base and a weak acid in there, both of those are going to help prevent it from going too far in one direction. Whether you try to add a strong acid or add a strong base, there's always enough to cancel it out. Cool. All right, now, why are buffers important? So there are many buffers in your own body because your body, for example, has very specific requirements in order to live. Let's think about this. What temperature is your body currently? Okay, if you're a healthy individual, about what temperature should your body always be? Tell me in the chat box, about what temperature should your body be right now? Do we know? If you put a thermometer in your mouth, what temperature should your body be? Yes, it should be about 98.6, 98.7, not 60. 60 would definitely mean that you are dead because you would have hypothermia, you would freeze. Okay, so 98, your body is about 98 degrees. Now, think about this. If you increase your body's temperature by just 5 degrees and you end up with a fever of 103, what starts happening when you have a fever of 103? Have any of you ever had really high fevers? Like just a slight increase. That's 5 degrees, guys. What starts happening to your body? Yeah, 104. Tell me, what were your experiences? Yeah, you feel extremely bad. You start to get delusional. You get hot. I started having like hallucinations because I was so feverish. Right. Yeah, you feel like you're going to die. And in some cases, if your fever gets too high, you can actually die. Like 105 can kill you. Okay, so here's the thing. Literally 7 degrees difference in your body is the difference between you being alive and you being too hot and dying. Or the reverse, if you get too cold, you can also die. All right, so it's extremely important to your body that your body stays within a certain temperature range. And that's true for many other things like acids and bases as well. Your body can't be too acidic, it can't be too basic, because again, you will die. There's a very small margin for error. Yes, exactly, Dolly. When I had a high fever when I was a kid, my mom would toss me into a cold bathtub, and it was the worst, right? It's a horrible shock to the system. But it helps your fever go down, which can be an emergency measure, right? Fevers are useful because fevers should help to attack any bacteria or stuff in your body. But in an emergency, if it gets too hot, then your body's actually working against you and can kill you, right? So, for example, buffers in your body. So, for example, there's a protein called hemoglobin in your blood. All right, so that's why you need iron, because hemoglobin uses iron. And so this helps to carry oxygen and carbon dioxide throughout your body. Okay, so your blood helps to transport these things. And so this protein in blood actually helps to buffer your body and keep it from getting too acidic or too basic. There's also buffers in your lungs that when you exercise, for example, you actually get slightly more acidic because you have a buildup of carbon dioxide and lactic acid in your body. And so there are buffers in your lungs to help offset this change and keep you from becoming too acidic. Same thing, your kidneys are in charge of maintaining acid-base balance by either excreting, getting rid of acidic urine or basic urine. So your urine can change based on what your kidneys are doing to make sure that your body stays within the correct range. Go ahead, give me a smiley face, everyone, if that makes sense. Smiley face if that makes sense. Okay, so all of these buffers help to keep your body in a certain range. Awesome. This is number 4 in your ticket. Go ahead, give me a green check when you have it saved. You have 30 seconds. Go. Okay, waiting on a few more green checks. It's Ashton, Brianna, Chanel, Damien, Dolly, Dylan, Edwin, Elias, Ethan S., Jacob, Jackie, Matt, Letty, Rozzy, Suji, Whitney. We're moving on in about 5 seconds. Again, I won't be able to go back after class because I have another class to go to, so you will have to wait until the recording if you miss anything. Looking good. All right, so the last thing that we need to talk about, probably a buffer that you've probably used at some point in your life. How many of you have ever used Tums? My husband, for example, has a thing of these next to his bedside. Because at nighttime, yes. All right, so Tums are a very common thing to use, especially as you get older, because as you get older, you get what's called heartburn. And heartburn is because your stomach is acidic and it gets up into your esophagus, and which is the tube between your mouth and your stomach. And as it gets up into your esophagus, it burns and it hurts. All right, thumbs up, everyone, if you know what I'm talking about. If you've ever heard someone talk about heartburn, if you've ever had heartburn, right? All right. Okay. So Tums can help with this because Tums are what we call an antacid, otherwise known as an anti-acid. Antacids, all right, what they do is they provide hydroxide ions, or OH negatives, to neutralize and decrease the amount of hydrogen ions. Because again, what happens when you add an OH to an H? What happens when you add an OH to an H? Tell me in the chat box. OH and an H make what? What does that make? Again, we should know this off the top of our heads. No, it doesn't make hydrogen. What does an H and 2? Yes, it makes, no, okay. I got no on there. Yes, it's going to make H2O, right? So an OH plus an H is going to give us H2O, which is water. So again, by adding these OHs, it neutralizes this out into water. Smiley faces if that makes sense. Smiley faces if that makes sense. Antacids provide the opposites, hydroxides, to create water when they bond with H's. And so this helps your stomach from becoming too acidic. Okay, now in some cases antacids can actually work too well, and antacids can actually make your stomach too basic, and so that means that antacids often also include buffers. Like for example, magnesium hydroxide acts like a buffer, right? Weak acid, weak base, so that if you accidentally go too far in one direction, those weak acids, weak bases, like we just talked about, can buffer and prevent you from going to either extreme. So they keep you closer to neutral. All right, thumbs up, everyone, if we understand. Thumbs up if we understand. So in order to prevent it from going too far the wrong direction, they also include buffers. Excellent. This is number 5 in your ticket. Green checks when you have it saved. Fill in the blank with the word decrease. Go, go, go. Oh my gosh, I'm so sorry you guys couldn't hear me. Okay, so awesome. So we've got these done, right? Everybody was able to fill this one in, looking good. Go ahead and give me a smiley face if you feel good about this. We talked about neutralization, acids and bases. We talked about pH and buffers. Smiley faces, everyone, if you felt good about these topics. Awesome. Thank you, Caleb. Thank you, Orlando, Shoshana, Andrea, Noah, Bradley. Awesome. All right, so I'm going to go ahead and send you guys your quiz really quickly. Remember, your quiz, all the answers to it can be found in your attendance ticket, so do them side by side and submit them at the same time. And here is your last word. Your last word for today is buff, B-U-F-F. That is for number 6, and I will see you guys later. Remember, if you missed anything, you will need to wait until the recording's uploaded because I do need to go to my next class right now. Bye, everyone. Have a great day.